All right, in this video here, we are going to practice a couple problems from 2.2. And again, you should have written down or have access to that checklist that I gave you so you can easily reference and understand why I'm saying what I'm saying before every problem as you hear this. Eventually, you're just going to get used to it because, again, this works for every equation ever, and we're going to be doing a lot of them this year. So let's go ahead and start here with number one. Number one, do I have any like terms on the left? No. Do I have any like terms on the right? No. Step number two, do I need to move any variables? No, I only got one. And it's on the left side, so that means that I need to step number three, move everything to the right to keep the v alone and isolated on the left. And what do I have here? I have a -9. What is that 9 doing? It is subtracting from v. So how do I move subtraction? I move it with addition. And what I do on the left, I must do on the right. So I'm going to add 9 here. Now, I like to put a line here because it helps me visually see all of the steps, especially once we get to more complicated problem that requires 5, 6, 7 steps. But you don't have to. I find that it helps. So I want you to try if you have a hard time keeping your work organized, because that's a really big issue that students have. Then let's go ahead and do this. So we have v is the only one that's alone. This is now gone. V, and how do I know I'm done? It's alone. There's nothing in front of it except for a +1, and there's nothing else. So I know I am done. And then 14 plus 9 is what? All right, so let's answer it now. So 14 plus 9. All right, so 14 plus 9 is 23. And then go ahead and check your work. If I have 23 minus 9, that does in fact equal 14. I am correct. All right, let's try this problem here. On the left, nothing to combine. On the right, nothing I can combine. Step 2, I only have one variable, so I don't need to move it. And this time, it's on the right side. And again, I want you guys to be careful because students like to move them all around. On the right side, I'm going to leave it, and that means everything that's on the right that's not t has got to go. So what is that 72 doing? It's getting subtracted from t. How do we get rid of subtraction? With addition. So I'm going to add 72. And then 4 plus 2 is 6. What about 4 plus 7? 11. And so therefore, we have this. T equals 116. Now, if you want to rearrange it at the end to make the t on the left side, you absolutely can, but it doesn't matter with this. And then I can go ahead and check my work. 116 minus 72 is, in fact, 44. I am correct. All right, I want to talk about this one because I know it looks a little bit different, and this is kind of what I talked about before with you guys, that plus or minus 18 is exactly the same as just minus 18. So you could see a problem look exactly like this, except this is the way it looks. Mathematically, these are the same, so don't freak out if you see them. This is just not considered the pretty version, but we'll just go ahead and work with it. So again, nothing on the left, nothing on the right. I only have one variable, so it's on the right side, so that means anything on the right has got to move to the left. Okay, so let's go ahead and think about this. Even though there is a plus sign, we're adding, that is a -18. So I'm going to go ahead and what do I have to do? I have to add it. So I'm going to be adding 18 to both sides, okay? So adding 18. I don't want you guys to get confused because you're like, well, there's a plus here. Yes, but the sign in front of -18 helps. Now, if it helps you, you could rewrite it to this, then solve it. If it helps you mentally do that. So I'm going to plus 18 on the right, and I'm going to plus 18 on the left. And remember, when the signs are opposite, you subtract and then keep the sign of the larger one. So for example, in this problem, -61 is larger, so it's going to stay negative. And then 61 minus 18 is 43. And that is the final answer. And then plug it back in and you will get the same thing. All right, let's do one or two of the multiplication and division problems for this video. And so same thing, nothing on the left, nothing on the right, only one variable. Move on to the numbers. That is a -4, but again, we're not going to add. What are we going to do? We're going to divide because that's -4 times a. So -4 times a, how do I get rid of that? Divide by -4, divide by -4. Remember, you want to divide by the entire thing, not just a 4. Otherwise, you're going to have a -a, and your signs are going to be wrong if you forget it. So be careful. And then we're going to do 48 divided by 4, or -4, and that gets us a -12. And then, of course, plug it back in. -12 times -4 is, in fact, +48. So if I go back and check my work, be careful with the signs. If I was wrong and divided by a 4, if I go back and plug it in, I would get a -48 as an answer, indicating something happened with my signs somewhere. Okay? All right. And then let's do number 9, because I want to have a couple of different examples here. Oh, no, I actually don't want that one. All right, let's go to number 10 next. So we have u over 8, okay? Now that is u divided by 8. And let's go through the checklist first. Nothing on the left, nothing on the right, only one variable. That's divided by 8, so therefore I need to get rid of it with multiplication. So I'm going to times by 8, times by 8. U equals, this goes away. U is nice and positive and by itself. -4 times 8 is -32. I am correct because -32 divided by 8 is in fact -4. I am correct. All right, I do want to go over and do an example like this because this one has a very unique thing that we could do here. So you absolutely can do what I did originally in the other problem with the division, where you multiply it by the -5 to get rid of it and move it to the other side. Or you could also do something called cross multiplication. I'm going to touch on that because we're going to go into that more later. But for now, I'm going to go ahead and solve it the other way that we've been doing. So again, nothing on the left, nothing on the right. 7 over 5 can't reduce anymore. So I need to check that for fractions as well. They can't simplify any further. I only have one variable, so I'm not moving anything. And then last but not least, if I go ahead and take a look here, I have k divided by -5. How do I get rid of that? I multiply. And again, I'm going to multiply by this -5. I'm going to multiply by -5 because that makes my k positive. And when I do the left, I got to do to the right. And these cancel out, and I'm left with now a -7. The negative from the -5 does still remain. Okay, and this is the correct answer. Now, when I want to go back to check my work, though, I want to note to you guys, this negative is on the outside of the variable. So when I plug this -7 in, I want you to note that this negative is the one from here. But in my k, I'm going to make this -7 over 5, right? Let me actually just lower this. So I'm going to make this -7 over 5 because it's on the outside. Now, 7 over 5 doesn't reduce, but I want you guys to know that is a negative on the outside. And it's timesing this negative. And a negative times a negative is a +7 over 5. So I am correct. It does work out.